In this section, we are going to discuss random numbers, tuples, and lists. Random numbers are widely used in computer programming, in computer applications, especially in terms of security applications and protocols. Also, it's useful in simulations where you need to generate random data for your algorithmic or academic model. You also have an interesting video link in the content that you should all see how important random number generation is in computer programming. So they have these lava lamps, and they are moving in random shapes. They take the picture of each instant, and then they generate random numbers using that digital form of the picture in order to ensure that cryptographic algorithms cannot be broken by generating numbers so that our data is safe. In our examples, we have much simpler codes that we use for generating random circles. So our turtle starts drawing a circle, and at the next instant it's going to draw 100 circles, but the radius of each circle is randomly generated by the computer. So every time we start our code, it's going to draw, for instance, if this was the largest, or I think this was the initial circle, it started with this amount. So if we stop this process and rerun our code, it's going to start with another circle. So I think it's larger than the initial run. So every time we execute this application, it's going to pick different random numbers and start drawing the next circle accordingly. So it's expected that these circles never repeat themselves at each iteration of the application. But that's not the case in mathematics. There are some theories that prove if you generate random numbers up to some extent, or if you generate many number of random numbers, you're going to end up generating the same numbers over and over. So I think most of you are going to see that in your mathematics class. And we can improve our code to draw the circles in the opposite direction as well. So the turtle makes a choice. It's either -1 or 1, so that it can multiply the radius with that number in order to draw the circle clockwise or counterclockwise. So we obtain this image when we try to draw 100 circles. Okay, so what are these functions? First of all, we have this randint function that we use from the random library. The random library is a standard library in the Python installation, Python interpreter package. So you need to import it before you start using that library. After we import it, we can use it as random.randint, just as we were calling turtle.circle to draw a circle, or turtle forward. It's similar. It's a library that we can use functions from. So we imported the random library first, and then From that library, we can use randint, which is going to return an integer number between 20 and 200. So we provide the lower and upper bounds, and we expect the random library to generate some numbers for us. You can print those numbers when you generate the numbers. So print radius is, so this is the random number we have generated, and we have assigned that value to we have assigned the value to our radius variable, and now we can print it before we make we start drawing. So each time it picks a random number, the program outputs the random number on the screen or in the terminal, so you can track it from here. They all are going to be between 20 and 200. And there is this choice function again in the random library, so you can provide a list of items. You can tell the random choice function to pick from -20, 10, -50, 11, 150. So this is a list. We define the lists with curly braces, and the choice function is pick either of those values, probably with respect to normal distribution, if not modified by the user or the developer. So it's going to pick either one of these 5 elements. In this case, there are 2 elements in the list, so it's going to pick either -1 or +1. So from there, we are going to obtain, let's say, -1 times 166. So it's going to draw the circle in clockwise direction. If it was positive, it would draw it in counterclockwise direction. So this is how it generates those circles. Another item container or data container is tuples. They are similar to lists, but tuples cannot be modified, unlike lists. You can add or remove elements from the list, but tuples are constant items, constant containers. So when you define the tuple using a regular pair of parentheses instead of the curly parentheses, so if you use the square brackets, if you use the square brackets, it's a list. If you use a pair of parentheses, it's going to be a tuple, and tuples cannot be changed, okay, cannot be modified. Tuple has a special feature, so if you don't want your list to be modified throughout your program, you can use tuples. Otherwise, if you're going to insert elements or remove elements from the container, you should use the list form. And on that list, now we can pick colors. For instance, we have this random integer function picking numbers starting from 0, going all the way through the number of elements in the colors tuple. So I'm going to discuss them all. For instance, the index of green is 0, blue is 1, orange is 2, and pink is 3, and so on. But the number of elements, let me write them all first: 5, 6, 7, 8, and 9. So the last element in our tuple is at index 9, but the number of elements in our tuple is 10. So we need to pick random integers between the number of elements in our colors tuple, which is provided by the len function. So len function returns the number of elements in the container. It can be a list, it can be a set, it can be a tuple or a dictionary. So the len function is going to count the numbers, count the elements, not the numbers. It's going to count the elements in the container, and it's going to return this the number of elements contained in the container, but the final element in tuples and lists is at index len, let's say tuple -1. So this is at index 10 -1, because there are 10 elements. As we start from 0, we don't start from 1. The first element is always at index 0. This has some historical meaning, going all the way to C pointers. So in C programs, the arrays are stored in the memory like this. So when you, let's say this is my list of numbers. So when you ask the computer the address of the list, it's going to return the position of the first element. So let's say it starts with 10 and 12 and 15, etc., and it's going like this. So when you ask the computer for the first element in the list, it's already present that you add the address of the first element to be 0. So you add 0 to the address of this list. Okay, so this is a detailed information. You don't have to memorize this all, but this is where it's coming from. And if you ask for the second element, you have to add 1 to the address of this list, because it's already pointing to the first element all the time. So this is actually an offset value for your elements. So the first element is residing on the 0 offset. The second element has an offset of value 1. So this all goes all the way back to C programming or older programming languages. So you should be careful that the first element is always at index 0, second element is at index 1, third element is at index 2. So when we pick a random integer starting from 0, now we have a color index value that is always guaranteed to be within this range. So it's always going to be either 0, 1, or 9, and it's never going to be 10. Okay, because we limit our randint function accordingly. And then we pick a color name from the colors tuple using the square brackets. So although we defined our tuple using a pair of regular parentheses, when we are going to obtain an element from a container like lists and tuples, and this applies to dictionaries as well, we use this square brackets. So the square brackets give us an element that is positioned at a certain index, which we obtained using this randint function. So this is obtained by the randint, and then we use this color index. We use this color index we have generated from the randint function and placed into our color index variable. There we use it for an access offset in our colors tuple. There we can obtain, let's say we pick the random number 3. We're going to go to the 4th position. So this is the 1, 2, 3, 4. This is index 3. So it started with 1, 2, 3. So we're going to pick pink for our circle, where we set the turtle pen color to be that color according to the random index. And then similarly we set the pen size to be some random integer between 2 and 7. So the thickness of the circle changes randomly between each iteration in our for loop. So there are going to be 100 circles. And also we pick the radius to be again between 20 and 200. Also from the earlier code we have this choice function that gives us either -1 or 1 that we multiply with the radius, so that we can either draw it in counterclockwise or clockwise orientation. So let's try running this and see the output. And you can always add additional lines of code so that you see the effect of random number generation or other functionality. So as you see, the thickness changes and the color changes. It's all random. It's not sequential. So it doesn't pick red after, let me see, red after pink. Just picks those numbers, index values randomly, and chooses retrieves the color value from the tuple using the access operator, which is this square brackets. So this goes on and on. You can play with it. Okay. So we have these examples that I have tried to explain you. Also, the choice function can receive the tuple itself, so it can pick from that tuple, but I wanted to discuss the indexing of those tuples and list elements so that you get familiar as soon as possible. Lists are also similar to tuples, but as I discussed, they can be modified. You can insert other elements anywhere in the list, or you can remove elements from the list, or you can append to the list, or so you can add other lists to this list, so you can enlarge your list with new items. Let's run the example first and talk about it later. So we have this color spiral code. It's a very short code, but the effect is, as you can see, rather complicated. It seems complicated, but it's actually a simple code that iterates by drawing lines, line segments, and the angle is intentionally left as 59 so that this spiral effect can be achieved. Okay, there's no randomization here, but we have a colors list. This is an example from the web, by the way. I think we have this. Okay, we have this link for the example, but I liked it. I wanted to include it in the content. It's simple. You would remember that the tuples had regular parentheses like this to start defining the number of elements, start defining the elements or inserting the elements. But the list have this square brackets. So the main distinction is how they are defined. But the purpose of the distinction is that tuples cannot be modified, but lists can be modified in the runtime. And let me see. So there is this star notation in Python that you can use to generate a list. So as you would remember from the earlier lectures, I was trying to print this range 20, and it was telling me that, okay, you're trying to print range 20. Okay, it was printing it as an entity. Here you have, it starts from, although I specified 20 only without 0, the form of the range is 0, 20. So it prints the range as an object, not the list of items in the range. But if you want to convert them to a list, you can use the star notation so that the items that are going to be generated by the range function can be retrieved as individual elements. Also, if you want those elements to be transformed into a list, you can use the square brackets so that Python can convert those elements to a list as if they were typed like this. My list is equal, my list is going to be 0, 1, 2, 3, 4. So you have this list in the output. So if you use the square brackets that are surrounding the range with the star notation, Python is going to automatically generate the list for you. Let's see if it can generate the tuple as well. So my tuple, it's not going to be a list anymore. And if I print this run, okay, cannot use starred expression here, so it doesn't allow us to generate tuples using the star notation that let me fix the code first. Okay, you can generate lists from the range function with the star notation, but you cannot generate tuples using the same notation. So this is another distinction between lists and tuples. Okay, there is another operator in Python which is called the is operator. It's actually a Boolean operator. It's a binary Boolean operator. It takes two arguments. Let's say A and B, or left operand and right operand. And it checks whether two operands are equal to each other. So let's first run the code. and discuss on the code. In the first part, I have a equals to banana and b equals to banana too. And if I check whether a is b, it tells me that a is the same instance as b. Okay, both of them are actually pointing to the banana in the memory. So in your computer's memory, you have something like this. This is the memory. Okay. When you declare a text, a string that is banana, okay, Python is going to insert it to a location in your computer, okay, in your memory. So it's going to stay here, banana. Whenever another variable tries to assign banana as its value, Python is clever that it's going to go and point to the same location in the memory. Okay, when I check whether a is b, it's going to check whether a is pointing to the same location in the memory and b is also pointing to the same location in the memory. So this is why a is the same instance as b. This is due to the nature of the string element. So when you define banana 100 times to different variables, they are all going to point to the same location in the memory. Okay, there will not be a second banana string in your memory. But if you define another string as a banana, this is different than banana itself, so Python is going to insert it to a different location, a banana, or maybe above here. Okay, so these two are different strings, but any other variable trying to access or being assigned the value a banana or banana are going to point to the same location. No matter how many you define, there will not be any other copies. So there is going to be a single copy of the same string, same sequence of characters and symbols. So this is why a is the same instance as b. The is operator returns true because they are all pointing to the same location in the memory. However, when you define lists, two lists with identical elements, as in this example, they both contain 1, 2, and 3. Our code returns false for a is b, but it returns true for a is not b. Okay, or you can call it like this, not a is b. It would also work. Let's try. Where's my cursor? Here it is. So you can also call it like this. If not a is b, this is also going to work because it's going to negate the result of a is b, which is false. A is not b. When you negate false with not, it's going to be true. When you use the not operator, it's going to be true and it's going to execute this print statement. Why are they different? So when you try to add a list containing 1, 2, 3, where a is pointing to, and when you define the same this is a different instance, although they contain the same elements. At some point in your program, you might be inserting elements to B, but not A. So they are different lists. You might be intending to modify those lists differently. Okay, you may keep one of them intact, and you can add or remove elements from the other, or the other way around. So these have to be different. So let's try it on tuples. First of all, we had lists, which are different instances, although they contain the same elements. If A is B, so let me just copy this part from here. If A is B, and then print this same instance, same, let's say tuple instance, tuple, control tuple. So let's run this code. A is the same tuple instance as B. So if we define these as tuples, they are similar to strings. So there's only one instance of a tuple. 1, 2, 3, defined in your memory. When you assign this to A, it points to this location, and when you bring in other variables, and if there is something defined as 1, 2, 3 to be a tuple, they are also going to be pointing to this instance. So tuples and strings cannot be modified. So if you modify them, they are going to be different tuples, but lists are inherently open to being modified. So Python chooses to assign different locations to different lists, although they might contain the same elements. But in terms of tuples, there can only be one instance of a tuple containing 1, 2, and 3. So any number of variables being assigned that tuple are going to point to the same location. So they are the same instance, in fact. So it's similar. It's similarly the banana or text, any other text, let's say CMP 150. Any variable referring to CMP 150 is going to point to the same location in the memory, and there's not going to be a second copy of either a string or a tuple, but that's different for the lists. So if you define the list with same elements, you're going to have different copies, different instances. You can also compare tuples and lists using the greater than or less than or equals comparisons. It's going to compare each element one by one, and it's going to decide whether 0, 1, 2 is greater than, so 0, 1, 2 is it greater than 0, 3, 4. It's going to first compare the first elements. Okay, they are equal. It's going to go to the second one. So the second element is not greater than the second element of the second tuple, so it's going to return false. Or similarly, this list also is going to be compared accordingly. So it iteratively compares the elements in each list. You can generate variables from a list or a tuple using multi-variable assignment operation. It's going to assign the elements in a list. Let's open it and modify the code. Okay, you have this, but if I try to assign a third variable from the list containing 2 items, this is going to raise an error. Okay, it says there's not enough values to unpack, so this is called unpacking actually. You got 2, but if I had a third one, have fun. You old. So I have 4 items in my list. If I want to assign 3 items from the list, I'm going to start from the beginning. Okay, it's going to try assigning have, oops, it's large. So it's going to start with have, assign it to x, fun to y, u to z, but there's an extra item that cannot unpack, so it raises this error here. So you have to specify the correct number of variables that are going to be unpacked, and the values of, it prints the x and y values. And you can also have a list of tuples, because you can have a list of anything, any type of data structure. You can have a list of lists, a list of dictionaries, or dictionary of lists, whatever. Also, you can have a list of tuples. So the elements inside the list are individual tuples. Here, this is a tuple, and this is another tuple, but the elements are separated with a comma. So this is a list, and you can unpack each item in the list of tuples variable to 2 different variables. So the first one, let me clear this first. So this is the first element, is going to go to the a variable, and the second element of the list is going to go to the b variable. So a is actually a tuple, a equals 1, 2, 3, and b is another tuple containing p and q. You can unpack those elements accordingly. Okay, there are more examples for the random number generation. So I think the position of the circle is okay. The rotation angle of the turtle is being randomly picked, so it doesn't always draw circles in this fashion. So it was drawing them either this way or this way. They were like this in the previous example. Now we are making the turtle. Turtle is always pointing to this direction. We make the alignment to point to another direction, so it can start drawing at other directions like this. So it can draw this different shape for you. Okay, let me close this example too. And the next example first completes the larger circles and then keeps drawing smaller circles on top of the larger ones. So we have the effect of that larger circles are in a 3D vision. They are placed at the back of the scene, and the smaller circles are placed in front. This is actually a 2D drawing, so there's no such thing as 3D positioning. But if you run the code, you're going to see that most of the smaller circles are going to be completely visible. If we did the other way around, we would not be able to see the smaller circles as clean as this. So it's not a clean drawing, but you got the point. So if you change the order of these drawings, let's say we start drawing the smaller circles first. Okay, let's take this above. And let's go up. And I'm going to take this from here to the third position. And finally this one to the fourth position. And if I run it like this, you're going to see that first the smaller circles are being drawn. And what I have is larger circles being displayed, but smaller ones are being overdrawn by the larger circles. So this depends on how you want to implement your code. But in principle, it's just drawings that are being that are overdrawing some other parts of the canvas. So this depends on how you want to implement your code. So you should practice drawing these tilted squares. You know what you would do. You would need to turn the turtle a little bit. So when you make the 90-degree turn, it's going to make an additional turn to your initial angle. Okay, you can also set the color mode. Instead of specifying colors as color names, red, green, blue, you can also pick from a range that is between 0 and 255. Okay, this is the maximum value you can set, because the colors we use in these examples are actually 1 byte long colors. So the smallest number that we can represent in binary within 8 bits. So this is a byte. There are 8 bits, and this is actually 1 byte. So if you look for the smallest number in 8 bits, it's going to be 0. Consider them all being 0. So this is the smallest number. The largest number is when you place 1 to each one of these cells. So this is 2 to the power 0. This is 2 to the 1. This is 2 to the power 2. 2 to the power 3. And this is 2 to the power 7. So this is 128. This is 64, 32, 16, 8, 4, 2, 1, and okay, that's 1. 1, 2, 3, 4, 5, 6, 7, 8. So this is 1, this is 2, 4, this is 8, 16, 32, 64, and 128. So if you sum these digits all together, so this is a binary number in mode 2 or base 2, it's going to be 255. This is why we can have values between 0 and 255. So if you combine these colors, you're going to get the intermediate colors, the mixture of those 3 colors, red, green, and blue. You can obtain different colors if you like. You can look up the color values on the web. So if you have a favorite color, you can use that value when you try to draw your shapes. I think this is all for this chapter. And we have covered the for loops, and we have seen the range function. We have seen block scoping, and we discussed the global keyword. Variable shadowing is where you define the same variable, a variable with the same name with an which is in an outer scope, so it's called shadowing. We have seen break and continue keywords. So break is used for terminating a loop immediately. Continue just terminates the current iteration of the loop, but it continues with the next iteration if there are any. And we have seen the for else structure. We've done some shape drawing with for loops. And now we have seen the random numbers, tuples, lists, and the is operator for comparing whether two entities or two variables are pointing to the same location, to the same instance, same element in the memory.